listening to the Electronics World. When we hear the word electronics, many students immediately feel fear because it sounds complex and technical. But if we slow down and start from the very beginning, electronics actually begins with something very simple, and that simple thing is silicon. Silicon is not a machine, not a circuit, not even a device. It is just an element that exists in nature. And yet, this simple element quietly runs the entire modern world. From the phone in your hand to the computer on your desk, silicon is found in the periodic table and its symbol is this. But in electronics, silicon is much more than just a symbol. It is the base material on which everything is built. This reason silicon became so important is not by accident. It is because of the way it behaves with electricity. In nature, materials are divided into three types: conductors, insulators, and semiconductors. Conductors are all metal, which allows the current to flow very easily. Insulators block current almost completely, but silicon lives in the middle. It does not allow current freely and it does not block it fully either. Electronics is not about letting current flow freely. It is about controlling when current should flow and when it should stop. That ability to control is why silicon is called a semiconductor and why it becomes the backbone of electronics. To understand why silicon behaves this way, we need to gently look inside a silicon atom. A silicon atom has 14 electrons arranged in different shells, and what matters most to us are the 4 electrons in the outermost shell, which are called valency electrons. These 4 electrons decides how silicon interacts with other atoms and with electricity. In a pure silicon crystal, every silicon atom shares its 4 valency electrons with neighboring silicon atom. This sharing creates a very strong and stable structure called covalent bond, where each electron is busy holding atoms together. Because all the electrons are tightly involved in those bonds, there are no free electrons available to move around. And since electric current is nothing but the movement of electrons, pure silicon, even though it is a semiconductor, allows most no current to flow. This is an important moment to understand because it tells us that pure silicon by itself is electrically neutral and most inactive. There are no extra electrons, no missing electrons, no majority or minority carriers, just a perfectly balanced and calm crystal structure. At this stage, silicon is peaceful but useless for electronics because electronics need movement and movement needs free charge carriers. This is where the journey takes a turning point. Engineers realized that instead of changing silicon completely, they could gently modify it and found that by adding a small amount of another element into a pure silicon, its electrical behavior could be changed dramatically. This process is called doping. Doping does not mean mixing large quantity or changing the base material. Silicon remains silicon. Only one impurity atom is added among millions of silicon atoms. Yet this tiny change creates a free charge carriers inside the crystal. Depending on the type of impurity added, silicon can be made to have extra electrons or extra holes. These free carriers are what allow current when we want it to flow. What makes silicon even more special is that it handles this modification beautifully. Its crystal structure remains stable. It tolerates heat well, it can be manufactured at large scale, and it is affordable. This is why silicon dominates the electronic industry worldwide. Every N-type material and every P-type material, every diode, transistor and integrated circuits still brings with silicon at its core. When you understand silicon, you are not just learning one topic, you are laying the foundation for your entire electronics journey. Once this foundation is strong, concepts like doping, N-type, P-type, PN junction and diode Stop feeling fear and start feeling logical and connected. Silicon quietly teaches us what even the most advanced technology begins with understanding something very simple, very small, and very fundamental. And thanks for watching this video, and thank you so much.